Hello. Am I using my right audio? Yes. It feels very strange to be just speaking to no one on my computer, but here we go. So today, just grab my keyboard. Probably no one will watch this, but I guess I should still do it as though someone will, because maybe someone will. This is about the first week's content for the subject I'm doing, which is called computer systems. And in computer systems, we'll cover a couple of different things. One is operating systems. As we all know and love or hate, Windows, Mac, etc. So not learning about those specific operating systems, but in general, like what is an operating system, how does it work, etc. And then also networks, which I don't really know anything about, like even probably what it is. It's about, computers communicating with each other, but it's what that will entail. So today we're going to talk a little bit about the basics of what an operating system is, and then also learn to do a couple of practical things, like using the command line interface on a computer. For those of you that aren't familiar with that, it's where you type stuff in rather than using the mouse. You'll recognize it when you see it from and about Git, which is a version control software that lets you manage different versions of code that you're writing, or you can use it for other things. Some people use it for books and stuff, keeping track of different versions and edits, etc. over time. So let's start with the basics of operating systems. It'll be interesting. I've only gone over this stuff quite quickly myself, so be warned, probably I will get things wrong. Great. So you probably have some sense already of what an operating system is, right? You have Windows, or you have Mac OS, and it's not obviously when you use your computer, you use certain programs, you use a Chrome browser or you use Zoom or whatever. And you probably have a sense that the operating system is not any of those specific programs that you use, but it's kind of those programs are all running within your operating system. Your operating system is kind of there, and then you run these specific programs. But the operating system is kind of the environment or the space they're in some sense. That's probably what it feels like. Maybe not. And yeah, so that gives us already some basic kind of intuitive sense of what an operating system is. But if we want to get a little more specific, so we have our actual computer hardware, right? So you've got your physical laptop, your physical or desktop or whatever it is, in terms of literal physical computer chips, memory, CPU, central processing unit, etc. And we also have programs that run on that, like Zoom, for example. But would kind of cause a lot of problems if we just had the hardware and then we had programs that we could load into that hardware and run. And so instead, we need to have this operating system, which is kind of a layer in between the hardware and the programs themselves. So why do we need that intermediate layer? Why do we need this middleman? Everyone hates middlemen, right? Well, so imagine you've got your computer hardware, your chips, your memory, your processing units, and you go, okay, cool, I'm going to write a program. I'm going to write this Zoom program that's going to run on the computer. There's like a few things that become potentially problematic here. So one thing is that like all the details of exactly how to sort of run the specifics of the hardware then have to be done by your Zoom program. I'm speaking kind of vaguely here because I don't understand the specifics myself. There's lots of basic things in like managing, I guess, like how it uses memory or kind of like different hardware things, like showing things on the screen, etc. I'm being very vague here. There's details of how the that your Zoom program would have to do, but then like some other program like the Chrome browser is going to also have to handle all these things, and so there's going to be sort of like a lot of redundant extra work that all these programs have to do to work with your hardware, and also like they have to be very specific, I guess, to that specific hardware that you have, right? Like you have to write something that works exactly with this, with the details of this hardware. Yeah, I should probably look into this a bit more to be less vague. I guess I'll learn more as the course goes on. So it's like a lot of extra work that each program would have to do in dealing with all the specific, really low level details of the hardware that you are, of the specific hardware that you're running your computer on. So that's one problem, like all this redundant extra work, which I guess you could think of like, yeah, maybe I'll get to an analogy later. And the other thing is that when you're running multiple different programs on the same hardware, which we normally do, you have a few different things running, then how do they kind of manage running together, right? So if one program is like using this bit of memory, this bit of RAM to run and do something, and another program wants to run what stops that program for the other program from just like overriding that same bit of memory, or they're both trying to tell the processing unit to execute commands at the same time. It's like getting conflicting commands at the same time, or just be kind of chaos, right? If they're all just trying to use this computer and there's nothing sort of managing like the allocation of resources and how they all sort of coordinate and don't fuck each other up or get into conflict. And so, and then I guess a third thing is that we want some kind of interface to just like interact with the computer. So look at the file system, start running a certain program, etc. And if we just have the physical hardware and run specific programs on it, we don't have anything to do that. So these are like three functions that operating systems can do for us, right? So I think like a good, I don't know, an analogy I've been thinking about is it's like having an office manager in an office where people are working, and maybe people that are even like doing quite different functions, or even like not working for the same company, like a co-working space or something. There's like a bit of a stretched analogy, but it's not like the manager, like a manager who's like telling everyone what to do, because the operating system isn't like saying, okay, this, Zoom, you have to open and call this person and do this. Like the user is just determining all of that. But an office manager, in the sense of someone who like manages the physical office, so they're like in charge of, ordering supplies, or ordering paper for the printer and sack for the fridge, and like managing, what do office managers do? I don't know. Oh, I've got to organize this repair thing, and I'm going to organize the system for like how we book meeting rooms, and I can do things like this, so sort of managing the physical shared office. And so there's like one of the functions that they can provide is dealing with the sort of low level details of things that might be shared by different people in the office. So say if someone wants to like, these are going to be very made up analogies because I don't actually understand how office managers work. But if someone wants to like, like print something, maybe the office manager set up a system where you just like send this file to this printing thing and it prints, rather than the person having to like, I don't know, buy a printer and like set up connecting to it and then like be making sure that it has enough paper and then ordering that. Very in doubt about this analogy. But yeah, it's kind of like the office manager takes care of all those like low level details, and then the person working the office can just be like, I want to print a thing, and that happens. So in a kind of analogous way, the operating system take care of all these low level details, and a program can just do something like, oh, I want to, print this thing to the screen, or whatever, and that will, and each individual program doesn't have to take care of all those low level details. And then the second thing being like managing these things all working together is super important, right? So the operating system might go like, okay, so this program's running, I've allocated this area of RAM of memory to that program, and that can manage that, but this one is allocated for this other program, and so they can't like use each other's memory, and I'll make sure that they always have enough memory, and also even sharing the processor time. So this is quite an interesting thing. So you, because most computers would not have, 20 different processing units, but you can run 20 programs at a time. You might get, I guess, a bit slow if you get up to 20. But you can run more programs than you have processing units. And how does this work? So, well, the first thing actually to explain here is like a terminological thing, which is a term process. Process is kind of like a program, but they're different. What is the difference? So a program is just the abstract thing which can be run. So like Zoom is a program. And then a process is like a particular instance of running that program. So it's like if you have, I guess, like a couple of different windows of the same program open, those could be different processes. You could be running it multiple times at once. An analogy that I liked from the lecture was that if a program is like a recipe, and then a process is like someone cooking that recipe. So you're actually like executing the program. And obviously you could have a recipe being cooked multiple times at once. It could be multiple people cooking it multiple times, or even, really one person could be cooking multiple batches at once if they wanted to. And so that's a process. The program is like the recipe, and the process is like the actual process of executing that recipe. And so really the question is about what happens if we're running multiple processes, because even if they're multiple processes of the same program, they still need to be coordinated, how you sort of allocate memory and computing resources, etc., between them. So you can actually run multiple processes on a single CPU, central processing unit, and the operating system can manage like switching the processing time between the different programs. So kind of go, okay, like this program will have access for this long, and then you get locked out and this other one has access, but it has to do this in a way that the programs themselves kind of like don't even know that they're being, getting it for a little bit and then being locked out, etc. I don't know, in the sense that like the program is not written to take account of this. When someone has just written this program, they haven't built in anything to deal with, stopping and going or anything like that. So the operating system has to like handle all of that and just make it run like as smoothly as if that wasn't happening. And I think they do this in like quite clever ways. So I might see like when if one program is kind of like not really using the like processing power for a while, it's like waiting for input or something, then it will like give that processing time to another program, etc. I don't understand anything near any details of this yet because we haven't got into it, but basically it's like allocating this between them. I guess you could kind of think of this like the office manager giving meeting room time to different people or something, but it's kind of like a more active version of that, where if they were like, I think the analogy is like not great for that. Maybe it's more like if the office manager also runs like a team of like executive assistants or something that they allocate between different teams depending on need. It's like, oh, okay, this team has a bunch of work going on, send a few over there. Actually, you're going to have to pause for a sec. This team's going to use them. Okay, that's also actually a terrible analogy. Maybe just the literal thing is more helpful, that it's splitting this processing time and giving these different programs a turn at it. Cool. So, and this also makes it like efficient, right? Because you could say, well, it's just this program. gets to use the processing unit until it's done, and then this other one gets to use it. And for one, that would be like annoying because you only do one thing at once, but it's also kind of could be inefficient, right? Because of the fact that, yeah, a program might not really be using the CPU much, or just be, yeah, waiting for input or something like that for a while. And so like the CPU is just laying idle, and you could then use that time to like run something from another program. But I think it's important to realize here that these switches is like at a very, very short time scale. So it's not like your computer is being like, you know, okay, Chrome, like you can now run for 2 seconds, and now Zoom, you can run for 2 seconds. It's like this mini microseconds or whatever the small sort of units are, such a way that you don't even notice, right? You can have like some be doing something in your browser, be doing something in Zoom or some other program. I've only mentioned those 2 examples. And you don't notice like, oh, this one's running a bit, this one's running a bit, because it's just switching at this super fast speed that you can't even notice. I'm kind of interested to find out more of the details of how that works, because it seems very like hard and ambitious. If I was like designing the first computer and someone was like, okay, you've just got one processing unit, but can we run like 5 things on there at once? I'd be like, what do you mean? I can't do that. That's too hard. You just do a thing and then you can do another thing. I only have one thing. I can't somehow magically make that do all these things at once. But people have worked out ways to do that, which is pretty cool. This is a handy little graphic actually that I will share to my screen, showing the layers. So you've got the hardware. Oh, by the way, on highlight. Yes. So 1 second, annotate. Oh. Yeah, so you've got hardware, like the literal physical computer. Operating system runs on that and takes care of running the low-level hardware stuff. And the applications like run on the operating system. And the operating system is like managing their resources. So going, okay, you can have this hardware now, you can have this memory, this thing, etc., and kind of interfacing between them. Maybe another analogy would be like an agent for actors. Would that work? Where the hardware is like the film companies and the operating system, like, no, that's also not a bad analogy. One day, maybe before the next one of these, I'll think of a good analogy. Yeah, and then you, as the user, use the application. The application is using the operating system, which is using the hardware. So yeah, it's the middleman between the applications and the low-level hardware, which I've now repeated myself many times. We talked about processors, CPUs switching. Oh yeah, so when CPUs switch between these different programs that are all running at once, that's called multi-programming. I think that's what multi-programming means. And so it is, yeah, because the CPU is just like one processing unit. So it can't like literally do multiple things at the same time. You can do that in other ways. Like if you have multiple CPUs, or like GPUs can be used in certain ways to run things in parallel. Actually, I'm not certain that you literally can't do any parallelism on a CPU. That's a good question, but definitely not as much as you like need to run these multiple programs at once. But you achieve something that seems like they're running at once just by switching really fast. Can you run parallelism on a CPU? Okay, seems complicated, and I can't tell immediately on a quick Google. True parallelism, actually being simultaneous, is not possible on a single non-hyper-threaded CPU core. Okay, so maybe there's types of special CPU core things where you can do some parallelism. Hopefully I will find out soon and then tell you. So anything else in these basics of what an operating system is? Okay, so one specific thing here, which is about a way that the CPU, or the operating system, kind of restricts what programs can do and how much access they have to the hardware. which you kind of want, right? Because you could like say, for example, we don't want a program to be able to sort of accidentally or on purpose just decide to, I don't know, suddenly take some memory that like another program is using, or to change some low level way that the CPU is like handling how it interacts with the printer or something. These are the things where the operating system to do to like manage the stuff that affects all the programs and manage resource allocation between them. So I guess the thing which I didn't talk about that much is like how the operating system provides an interface that you can use to put input and to start and stop programs and stuff. We didn't really actually talk about that much in this first lecture. I saw that more when I was like Googling about operating systems. But yeah, that's also obviously an important feature. Anyway, what I was saying was that, yeah, you don't want programs to be able to do all these sort of more manager level functions. Like, you know, maybe if the office manager is managing the shared office, you don't want individual people working there to be able to just go in and like change something with a printer or something. I mean, with that, obviously, maybe you will if you have a chill office, but you could imagine things like that. Or maybe you don't want individual people to be able to like change the office temperature or something, because that's like the office manager does that and they check in with everyone about how the temperature is going and then they change that. And you don't want just like individual people to be able to do that. Or maybe you don't want them to be able to just like go into a meeting room. It's like it has to be booked and the office manager has to approve it because they know when people are available and have requests or something like that. So the way that we do this with the CPU, so basically like a CPU, CPU can do a whole bunch of things. Some of those things we only want the operating system to be able to manage. And then other stuff we are fine for the programs to do, because obviously they need to use the CPU to run, but we've got to kind of, and memory, but we've got to restrict what they can do. So the way we do that is that there's, certain things that are restricted. So like an example of that would be like writing to output. I guess this is a bit complicated because I guess it means output more if you're doing like a command line thing. And then, but writing to output is an example. For people who haven't used command line stuff, this might be a bit confusing so far, though we will talk about command line basics in a moment. And so you don't want a program to be able to just do that on its own, but sometimes they need to do that, but you want to run that request through the operating system, right? Because that's the one that's managing everything. So it's kind of like how you maybe don't want someone in the office to be able to just go and start using a meeting room, but you do want them to be able to use meeting rooms, but they've got to kind of run that request through the office manager and be like, hey, I want to use and book this meeting room. Can I do that? So we do a similar thing to that with these restricted processes for CPUs. So if you're writing a program and you want it to do something like this, like you want it to write to the output, you do something called a system call. And this is when you send a request to the, it's like you send a request to the operating system, which then does the thing for you. I guess if it's okay with doing that, and then switches you back to normal mode. So we have names for these different modes. So like CPU, when CPU is in user mode, it's when it's just like running a program and doing the things that individual programs are allowed to do. So user, I think not in terms of like me as a user of the computer, but more the program is using the CPU to run. So Zoom is using the processing unit to run Zoom, and it's doing the things that programs are allowed to do. There's certain stuff that's restricted. But then when it wants to do, I think another example of a system call is like getting the time from the computer's clock or something, I think, just from memory of writing programs to access that. And so when you want to do something like that, you do this thing called a system call. Then the CPU switches into this other mode called kernel mode. This is like the unrestricted thing. This is like it's now is doing, can do all the things that the operating system has control of, that the office manager has control of. It can, get the computer clock time, can write to output, can do anything unrestricted. So it switches to, so you kind of send this request, it switches to this unrestricted mode, executes that special request for you, like getting the time from the clock, and then it switches back into the user more restricted mode, and the program keeps running. So we don't just give programs free reign of these things, but they can file a request, switch into that mode, gets done, go back. I don't know like exactly how, or if there's ways that then the operating system would be like checking these system calls and maybe not necessarily running them and stuff. I would assume that would be the case because the point is kind of for it to manage these things, but I'm not sure about that. Hopefully we'll find out soon. So yeah, so one thing about system calls is that they are actually expensive because you have to switch into this kernel mode to execute them. So they take longer than just like a normal command you would put in your code. And so I guess it's important to be aware of that when you're programming. Like if there's a way you could do something with heaps of system calls all the time, or if there's a way you could do it without them, I assume it would be better to do it without them because you're not having to switch these modes back and that being like inefficient and time intensive. Yes. Great. So that's all the basics of operating stuff, actually. Yeah. If someone is watching this, definitely also feel free, well, not even feel free, like do send me questions because I'm sure there's things I've said that are not that clear and it'll be helpful for me to have questions about them. Great. Actually, we'll have a quick pause break here because then we're going to go into some more practical things, basics of the command line interface and using Git version management. Can I pause the recording? Yeah, I'm going to pause the recording. Okay, break over. I hope you had a nice little break for yourself as well. So second part is going to be more hands-on and it's also going to be more like flying by the seat of my pants because I kind of like skimmed over these bits from the like tute instructions and haven't really like done or understood them properly myself. But I guess maybe that just makes it more interactive and fun. If I was actually teaching someone, maybe it'd be more useful. Like if there was someone here, it'd be more useful to like know and be able to teach them. But seeing as it's just me, the fact that I'm like kind of learning on the spot might make it more engaging. Cool. So we're going to start with the basics of the command line. So if you're someone who has never done any computing stuff before, you probably have not done this before or might not even know what it means. I think, let me share my screen here. So this is a command line interface. I think you can see the screen now. You've probably seen stuff that looks like this, even if it's just in movies or whatever. This is not a program that it's not like you're writing a program here that will run. You can think of it as like a equivalent to like Finder on a Mac or File Manager, whatever it's called on a PC, like literally just the thing where you open up and then you can navigate through your directories and go to like My Documents, schoolwork, open Word or whatever. That's like a way that you can navigate through your file system and open things. And yeah, you can kind of think of the command line as an equivalent for that, but then it also can like do a lot more, I guess, than what you can do with that file system or sort of in easier ways and stuff. So you can kind of think of it as like a nerdy, super powered version of just like clicking through your files and or something. Yeah, I'm kind of not certain that's the best description. Maybe some people would be like, what? You can do so much more with the command line. It's so much more than just an analogy for a file system. But maybe that's an easier starting point to think about it. And so the difference is that whereas with the file system, let me even switch to that. Can I share that? Oh, it's not even letting me share the file system thing. I guess I can share my whole screen. So the file system, it's like visual. So you visually click through, you go to writing, okay, open this thing or whatever. So there to there, some AI art for you. With the command line, it's all text-based. And this means, yeah, you can do like a wide range of things, lots of things, I guess, more quickly and easily, because rather than having to, navigate and click through to some certain command to do something, you just type it in and it's done. So let's start first with the basics of just navigating around directories or folders, as you know, the normies call them, in a using this text command line rather than the normal visual folder system. So just a second, I'm just checking that is what I plan to do first for this. I just like wrote down from the cheat sheet all the like commands that they had you learn, and then I'm like, okay, I'll just have this list of commands and then we'll go through and explain things. Let's see. Okay. So there's some things here about like specifically uploading stuff to like the virtual machines that we use in this course and stuff. So I guess I will like skip that for this and then do that later myself. Cool. So the commands I'm going to be using are things that will work on a Mac. If you're on a Mac, you can open the command line by, I think if you just go search for like terminal. Is that what it's called on a Mac? Mac command line. Oh, what's going on? My keyboard's disconnected. Oh, my Bluetooth is off. Turn that on. Yeah, I'm just checking if that is what it's called on a Mac. Yes, it's called terminal. So you can just like search for the terminal program and run that. And so the commands that I am using here will work on a Mac. I actually don't have a Mac, I have a PC, but I'm running on like a virtual machine on the uni's computers that is running, this is also not running Mac OS, but is a Unix system. Is running Linux, I think, which is another operating system, and has the same command line commands. Windows has different commands, but if you're doing this on Windows, yes, actually these commands won't work. You can like set up things in Windows that can do this, but I think that's beyond the scope of what I'll explain here. And also, I still don't understand a lot of that properly. But you know, if you do want to learn Windows things, just ask me, or you can Google it. But it's always nice for me to have an excuse to explain something. Great. So if you're assuming that you're on your Mac and have terminal open, what can we do? So first we can say, well, where are we? Like when you're doing the visual thing, I'm just switching back so I can show you the visual folder system. You can see what folder you're in because you can look up here and you say, okay, we're in images, AIR, go back and you know what folder you're in. Here, how do we know where we are? Well, actually this little test here is telling me in a folder called git test. But you can also do a command pwd and that will give you where you currently are. Home, JLL homes, git test. So that gives you that simple info. What are some other things that we want to do on, actually, I might do this in a different interface that will let me actually have more folders and stuff to work with. Oh no, that's not using the right thing. 1 second, sorry. Okay, yeah, great. I'm going to use a slightly different interface. Cool. So this tells us where we are. Now, what if I want to see like what is in this directory, right? That's what we do with the physical file system. We want to just see like what are the folders and files here that I might want to open. But here, this is just a blank screen. I don't see anything. Well, if I type ls for list, at least I think of it as list, then that would show me, oh, this is what I've got. These are all these files. Maybe I shouldn't be just like showing all my files and things on the video. Is that bad? Will like a password or something come up? Maybe, I don't know. Okay, switching back to the other thing. So PWD tells us where we are. ls shows us what's here. In this, because it's like a new directory, there's actually nothing there. Actually, don't worry about that command. I'll explain it later. So, oh my God, the coloring here is so bad. That says git test. Can I change like the colors? You can't read anything. Colors, okay. Changing the background to black. Oh, that didn't work. Let's try again. Okay, this is annoying. So we've just got this one folder, git test, super hard to read, sorry. And that's all that's here. Now, what if I want to go into that folder? Do cd for change directory. /git test, which is the name of the directory. So what is this .test? Dot is saying starting from where we are currently, and then we want to go to the git test folder within that. So that has changed us. So we now moved into git test. So now if I do pwd, I am in home JLL homes git test, whereas before I was in home JLL homes. And then if I want to see what's in this folder, again, I can do ls solicit it, and there's actually nothing in here yet. But maybe I want to make a file. How might I do that? I can do touch funtimes.txt. And now, oh, someone has entered the waiting room. Hello, David. Hello. This is very mysterious. Which David is this?
Oh, which David? The best David.
Hello, David. How are you?
Good.
Nice to see you. I've been doing this. I've just been doing this to no one. I've just been recording it and just explaining things to help me explain it. But now there's a real person here, so this will be extra fun.
You've got
this is being. I am recording this, by the way, just so you know.
Yeah.
I'll probably put it up.
Yeah,
there. Yeah.
I did it on when I logged in.
Oh, cool. Yeah.
Although I don't know. Yeah, some might not really have clocked that.
Yeah, I'll put it up somewhere.
So, what do you got going here?
Yes, great. So far, I'm teaching just the basics of command line.
Yep.
So I'll be teaching things that you know. I guess you can also just correct me on things. Earlier I did. So first I was explaining because this class starts with operating system. So I was explaining the basics of like what an operating system is and what its job is in the general in computers. And then we've now switched to the more practical part, which is basics of command line and then Git. Yeah.
Nice.
Yeah. So I'm trying to think of how to make this like interactive now. It'd be easy if you didn't know any of this because then it would be generally interactive. But I guess maybe I can just act as though you don't know.
What's the most advanced thing you've done?
Well, with the command line so far, the most advanced things we've done is to change directories. Maybe you can like just act as though you don't understand things or something.
Yeah.
Okay.
Why is it all in lowercase?
I have no idea. Also, the colors, like this, whoever designed the colors for this is for PowerShell is terrible. Like you can't, the default color for directories is like the same as the background.
Yes.
And I spent time trying to change it, but then it didn't change. So do you know how to do that? That would be great.
Well, firstly, it seems that you have it in Spanish or something.
Oh, yes, it's in Portuguese. That's an essential part of using this.
That's great. I like doing that kind of thing too. Or no, it would be, I don't know, go back to it. Go back to the window where you make the changes.
Yeah.
Was
Screen text. Oh yeah, so that means screen text or something.
yeah,
That's background, like background screen, pop-up text, and then screen pop-up background screen.
Change the opacity down the bottom. That's really fun.
Okay. I think it's just not doing anything though. I think maybe I have to restart for it to make a difference or something.
Maybe. Or
okay, I'll try restarting. That was. Oh, hang on. I ran into Jonathan the other day. He was on his way to play tennis with you. Did he say hello for me?
I don't
Jonathan.
know that he did that. No, he talked about
Jonathan.
you because he was trying to. No, he brought you up straight away because he was trying to remember your name. I think in all of that, it might have got lost that.
Yeah.
He just saw you, but he said he'd see you around a bit.
Cool.
He's pretty sketchy on the first cast. Good times. I guess, I mean, it was so soon afterwards, we then put it on again and it was so full on, it's sort of hard to even remember the first time. But that was enough going on there as it was. While you're restarting that, there's a really good book that I have in PDF called Pro Bash Programming.
Ooh, cool. Maybe you can...
The gun, and I'm going to give it to you.
Thank you. Maybe you can like throw in some advanced things as I explain things. You can be like, maybe you can simultaneously act like a complete novice and throw in advanced things. Be like, wait, what does LS do? And then be like, and did you know that if you want to do this extra thing, you can do it like this? I'll leave you to determine your own character role. So how do I? Because I have to connect to virtual machines. How do I do that again?
What are you doing? Cool.
Sorry?
I said you're, connecting to a machine.
Yes. So those watching, I am connecting to the Unimog virtual machines. Is that the code? Hang on. What's it called? What am I SSHing into? Bear with us. 30,023. Please work. Yay, it worked. Great. So I'm now running Linux on a Unimog virtual machine. Okay, great. The colors are now better. Oh, wait, can you see this? Am I sharing? Yeah, cool. Great. So we were talking about basics, about just seeing what directory we're in and then seeing what's in that directory. Let's make something else in that directory. That's fun. So to do that, we want to make a directory. A directory, David, is what we would normies like you who don't know anything about computer programming yet would maybe call a folder. But if you call it a directory, then it sounds much fancier. So always call it a directory instead. That's the most important thing from this whole class.
So MK folder won't do anything.
No, because I think that you're, a boring civilian. So you want to make a directory. So we mkdir. And if you're all the specific instructions, you won't remember them at first. You'll just like Google them and be like, what was that again? And then when you use it a bunch, you'll remember it. So don't stress too much about remembering. But we want to make a directory. What folder do we want to make, David? What should we call it?
Something with capital letters.
Something with capital letters.
And little letters.
Capital.
Yes, call it capital.
Okay, did it work? Let's see what's in this directory. Oh, look at that. Get test and capital.
Can we test if capital is a directory?
Yeah, good question. I guess I'm just going by knowing that it has like different font colors if it's a directory or a file. But I guess we could do like this work, file capital. There we go.
Oh, I didn't know about that.
I just learned that about 30 minutes ago when I was watching up for this.
Single or double square brackets and then -D and then capital.
This?
Yes, you'll probably need spaces. Okay, you'll need an end to it, but you also
that's a flag.
Space. Yep.
This?
Yeah, the end one. So if you press upwards, you get the.
Where's the end? The end's here?
Yeah. Yes, but with a space.
If
you press up, you get the previous command.
Yeah, I do. I don't know why I'm not doing that. It's not a lack of knowledge. It's just a presence of stupidity.
Now maybe try 2 brackets at the beginning and end. Yeah, that's fine.
No. Anyway, we can also achieve this with file. So file, David, this is something you actually didn't know, so I can actually explain it. It just tells you what type of file something is. So it tells us it's a directory, but it would also, so if we make, say, a text file, and how might we do that?
How might we do that?
I might go touch, what's our text file? What's in the capital?
What is in capital? Chapters, chapter 1.
Chapter 1, great. Chapter 1.text. Now, David, why have I done a dash there rather than just a space like a normal person writing something?
That would maybe make 2 files or something.
Yeah, I think it would. Well, let's try it. It will get confused.
Space is generally
yep, it makes chapter and it makes 1.text, exactly.
Yes. Space is the main delimiter or whatever you call it in
oh yeah, that's a
bash.
Good word for it. Yeah, so it takes it as a separate command. We can make things with spaces in if we want to. I won't get into that now because it's simpler to just put dashes in things, and you can clearly see what is a single thing called chapter 1 versus chapter and then 1.text. So
set the delimiter with capital IFS, I think.
IFS?
Well, I don't know if that would help you here, but sometimes you need to change it. You want the delimiter to be dashes or something. Or
you can change it.
Whatever.
Yeah.
You can change it.
Yes. Very advanced. So now we've got this chapter and this 1.text, which isn't really what we wanted. So maybe we want to get rid of those files. How can we get rid of these files? Well, I'm glad that you asked, David, because what we can do is we want to remove them. And how would we spell remove if we really didn't want to use any ink? We would spell it RM. So we want to RM the 1.text and the chapter. And there we go. It's done. Well, is it done? Let's find out. LS. Yes, it's done. So there we go. Maybe this would be more interactive and dynamic if you are the one typing and then I'm explaining things. Would that be a better dramaturgical structure?
Great. You want me to share?
Yeah, great.
So you need to stop sharing your screen.
Yeah, and I think I have to enable something.
Yes.
There you go.
Here we go. You see that? So
wonderful.
So this is my main folder, I guess. Okay, so you're seeing all of my things there.
Yeah, this is all going out to the internet. Enjoy.
Yep. Maybe we should be somewhere else.
This is what happened to me earlier before you came in. I was like, and here's my thing. I was like, maybe I shouldn't. Let me make another folder. Let me go on the virtual machine. I guess if you just go into a directory, then yeah.
Make directory J.
There we go.
And then clear.
Ooh. See, I didn't know that. So it clears the screen. Great.
All right. So if we make directory capital, and there it is. So what I often end up
Capsule,
doing.
even.
Yeah, exactly. That one.
How would we rename that, David? We wanted to. Oh wait, I meant to be new things. How do we? I think we move it, right? We go move.
Yeah, we can move it from
where it currently is.
Capital, and we can probably, if I press tab here, it'll finish it for me.
So people watching might be saying, "Why are we moving something? I thought we were renaming it." And I guess we would just say, "Well, renaming is kind of like moving." So you can.
Well, only if you're having it in the same directory. If the thing itself is staying in the same directory, then you essentially are renaming it.
Yeah, exactly. It's like you're either, it's like you can change the label on the file folder, or you can get another identical folder which has a different name. You can't really tell the difference. Great.
Now pressing the up arrow to go back through things I've just done.
Yes, that's a good tip for our
we have this. So I put a C and then I press tab and it automatically finishes that for me. So tabs and automatic finish.
Autocomplete, kind of like a primitive autocomplete. Yes.
Particularly for folder names. So here we've got an if. So we're starting an if statement. And these little square brackets mean...
Oh, wow. This is getting very advanced. This is beyond...
So basically, we're testing the capitals of directory, and then we're going to echo yes if it is.
Yes. Okay.
Yes.
There we go.
There you go.
And what was our alternate way of doing this?
What did you have? File, capital.
There we go. Directory.
Yeah.
Well, maybe we can test out this file function a bit more, David. What if we wanted to see if it works for like text files or something? What could we do there? We might want to make a text file.
All right. So
remember how to make a file?
Sure, but I make a file like this.
Oh my God. Confusing the students. Oh.
This is basically the command to write into something.
Okay.
So if I echoed something or had something on the other side, if I had an output on the other side, it would go into the text file. But as it is, that's just going to make an empty file.
Ah, cool. There you go. And what will file tell us about this? Empty. Huh. Okay. That's the type of file that it is. Yeah. An empty file.
The endings don't really have any meaning.
Yeah, right. The operating system. So I wonder what file is meant to do then.
So there's different ways that files are identified. Often by the first line has something. If it's a bash code thing or thing, the first line has something important in it.
Yeah.
The first line of a bash script is often hash, which means comment. So if I do that, it just does nothing. So hash is a comment in bash.
Yeah.
So it's a no command. I just did a no command. Anything that comes after the hash is just ignored.
Oh, cool. I didn't know that works for bash. Handy.
But this is the way, like a first line of a bash program is often this. So it's called shebang or something. And then this is the command to get to bash. So the file knows in that way, the operating system or some things can tell in that way that this is going to be a bash command line thing. If it's a certain type of image thing, then often it says that at the top of the thing. If it's a PDF, it says something on the first line.
Yeah, right.
So it's it's not just one system. It's a bit of a mishmash as to like what the file actually is.
Let's move on to another handy task we might want to do.
Yes.
Just wait one moment while I Google what this command does because I've never used it before.
What is it?
So WD. This is going to change our working directory. But what is a working directory? So let's try WD to some new directory. Maybe we can use our capital directory.
WD does nothing.
So if we WD capital. It's not there?
WD is not in my...
Huh. Let me see if it works for me. Oh, it's also not found for me. Interesting. This was just in the cheat sheet that I read.
apt
WD command.
Install WD.
WD commands. WD takes a string right argument.
Right.
Maybe it's not a command. Maybe it's just WC. Okay, maybe we can just ignore this.
Wait, what are we trying to do?
I don't know. Hang on. Let me look in this sheet. WD.
WC is word count.
Yeah, but what's WD? Oh, I think it's okay. I think it's nothing. I think I somehow. Oh my god! I think I just.
And now
Maybe it was meant to be PWD and I didn't copy all of it. Who knows? Let's forget that ever happened.
All right. Now I've word counted no file, so I'm now stuck without being able to get back to the command line. And I forget. Control D. Oh, whoa. Okay. Control D twice has got rid of that screen. So we'll just.
Oh wow.
We'll come back to that. Where were we? Come back. Share screen. All right.
Great. So here we are. So if we want to, do we have our text file there now? Our empty text file? What's still in this directory? Yeah. If we want to read what's in there, we can do. Well, I'm curious how you would do that because there's a bunch of different ways to do it.
If we just want to see what's in it, we can do cat.
Great. That's also what I had from the sheet. But it's empty, sadly.
How can we get something in it?
Yes.
Glad you are. Echo. Echo is a nice ancient command. That'll just echo out whatever you've done. What should we have here? What should we echo? And just echo, which will give you echo. However, if we echo it into our text file, then we have it in the text file now.
It's in there.
And now if we echo hello into the text file, what's going to be in the text file now?
We're going to have just hello. I'm guessing. Yes. Overwrites.
And what about if we do this?
Oh, I don't know what that is. Maybe it'll be hello on different lines. Yes.
Appending. So two appends and one deletes what's there and starts again.
Interesting. Very interesting.
So often you, like at the beginning of something, you start by making a new file with just the one thing. And then after that, you append things into it.
Let me write these down.
By the way, we should note it's International Women's Day today. And there is a march in the city at 5:30 or something near Treasury.
Cool. Maybe we should change our file name to be in honor of International Women's Day. So we have overwrite file is, you can just echo stuff into the file. And then if we want to append, we can go echo more stuff. And spaces don't ruin this command.
Which command?
The if we do echo some things into the file, like if you write echo hello there, what will happen?
No, it'll all just go in as one line.
Great.
Wonderful. If you want to, I mean, you should probably like, this is kind of clearer. Well, kind of want it to be like that.
Yeah. Hello there.
But you can then see, how can we go into? I don't know. Well, if you're writing it in a script anyway, you can do multiple lines after echo if they've got braces around them.
Well, that's much too advanced for us. Well, we've actually got some little question exercises here. So maybe it'll be more fun to do those. Maybe we can take turns doing doing exercises. Great.
Mm-hmm.
Where are the exercises? They say exercises in 3.4 and 4.1.
Oh, 4.1. They're still doing 4.1.
The positioning of the, like, it's using specific files. Okay. I think I have to do this because it's using specific files that are on the system. So I will share my screen. Okay, so what do we have in this directory? Oh, I have to load something. Or what do I have to do? Download a file from the LMS and upload it to your server.
Cool.
That's
getting advanced. So how's this pedagogy of teaching going?
Yeah, I mean, so far it's good. This is the first one I've done of it. Mm-hmm. I mean, I feel like it's like a good like artificial deadline just even because I'm like, oh my god, I've got to like understand this thing by 3 because I'm going on Zoom to explain it. Yeah, I think it feels more fun so far.
Yeah.
And so yeah,
and I'm sure a study has been done, and I think 95% of learning that actually happens is done by teachers as preparation to teach something.
Oh, that's so funny. Yeah. That'll make a lot of sense. Well, here we go. I'm leaning into that.
I mean, one thing that's definitely true is that the comprehension. One's comprehension of something after teaching it is way higher.
Yeah, totally. Totally. I'm actually gonna quickly go to the toilet. I will meet you back here in a few minutes.
Right,
cool. Okay.
If you unshare your screen, don't mind. Right,